Alright, this video is on fractional powers and using those fractional powers in simplifying radicals. Before we start, let's take a good look at what fractional powers actually mean by using the rule, which would work like this. If you have x to the a over b, there's your fraction a over b, which is the exponent. What that means is b becomes the root and a becomes the power on the x. Now that's a little harder to understand than actually seeing an example. Once you see an example, it'll be perfectly clear. But I wanted to alert you that before we get to an example, that can also be written as the b root of x all raised to the a power. So the power can either be, the little a can either be under the radical or outside the radical. It has the same effect. It's usually easier to have it outside the radical, as you'll see once we start some examples. So let's go to a very simple example first. Let's say we have 4 to the 1/2 power. Well, the 1/2 power means that the 1 is the exponent on the 4 and 2 is the root. So we have the 2 root of 4 to the 1. Now the 2 root means the square root, so we don't really need that 2 there. It's understood anyway. So this is the square root of 4 to the first, and the square root of 4 to the first is the square root of 4, which is 2. You don't need all those little steps once you understand the concept. Let's move it up a notch to a little more complicated example. Let's go 8 to the 2/3 power. That means, remember, the denominator is a root, so it's the third root, or the cube root of 8 squared. Well, that's the cube root of 8 squared, which is 64. That may be a little harder for you to sit and think about. That's why I want to do it the other way, which is you take the power, the 2, and put it on the outside. Because it means either way. You can either look at it this way or this way. And the second way, as I said earlier, is a little easier to work with. So we do the cube root of 8, which is under the radical. So you do that part, which is in the parentheses. The cube root of 8 is 2. And then outside the parentheses, you have a 2, so 2 squared is 4. And that's the final answer. So 8 to the 2/3 power is equal to 4. Let's do a couple more examples similar to those. Let's throw a negative in there. Let's go negative 81 and raise that to the 3/4. Now you got to be careful with that negative sign. That negative sign is outside of the radical. It's like negative and then the rest of the problem, 81 to the 3/4. So when the negative sign is not inside the parentheses, that's the last thing you want to deal with. So we're gonna pretend like it's not even there for a while. We'll carry it along, but we're not going to deal with it to the very end. So 81 to the 3/4 is the fourth root of 81, and we're going to put the cube outside the parentheses, which is a little easier, because we wouldn't want to cube 81 first and then try to figure out what the fourth root of that is. So the fourth root of 81, you think, well, let's see. Is there a small number that you multiply by itself 4 times is going to equal 81? How about 3? 3 times 3 is 9, times 3 is 27, times 3 is 81. So the fourth root of 81 is 3. So we have 3 inside the parentheses, and a 3 outside the parentheses is the exponent. 3 to the third is 27. And now I bring my negative sign, which I don't want to forget, over, and the final answer is negative 27. Now we'll take a look at some examples that contain exponents. Let's start off pretty simple with the cube root of n squared. Okay, so this is going backwards, where we remember that the number under the, or inside the little radical sign is the root, so we want the cube root, and that goes to the denominator of n squared, becomes n to the 2/3 power. That's pretty simple. Let's go with a little more complicated problem. How about the cube root of 8, a to the 5th, b to the 3rd. Okay, you kind of do one thing at a time here. First you do the cube root of 8, and that is 2. 2 times 2 times 2 is 8. So the cube root of 8, that comes out as a 2. Then we have the cube root of a to the 5th. Well, a to the 5th is actually a to the 3rd times a squared. And when you take the cube root of a cubed, that just becomes a. So an a comes out, and that's a squared, and a squared stays under. And b cubed, same thing. The cube root of b cubed is b. That comes out. So there's your final answer. That's all you can do. Now the shortcut on these is when you have powers under the radical, what you can do is take the root and divide it into the power. For example, let's go back to that 8 to the 5th. If we take the root 3 divided into 5, that goes once, just simple division here, with the remainder of 2. So this is what comes out in front of the radical, and this is what stays under the radical as the exponent. Let's take another one like that. We'll use that shortcut. Let's take we'll do cube root again. Cube root of, let's say 24 a to the 7th, b to the 4th. Alright, now the cube root of 24, that's a little trickier to think about, but if you think of the factors of 24, 24 is the same as 8 times 3. Well, 8 has a cube root. We're familiar with that. We've seen it a couple times already. The cube root of 8 is 2, so 2 comes out. And we're going to have a 2, and then we're going to have a cube root. I'm going to leave a little space there. And the 3 stays under. Now for the 8 to the 7th, again, you divide. 3 goes into 7 twice, so that twice is what comes out. A to the twice power, a to the 2 power. And there's a remainder of 1. 3 goes into 7 twice with a remainder of 1. So that 1 is what stays underneath the radical. One more time on the b to the 4th. 3 goes into b to the 4th. 3 goes into 4 once. So 1b comes out with a remainder of 1 that stays under. And we'll write this without those 1s. We don't need those. It's a little silly. So we'll write 2a squared b cube root of 3ab. Not as complicated as it looks, but using that little division technique makes it fairly simple. Alright, now we're going to simplify some radicals using those fractional power properties. We'll start with the cube root of 2 to the 9 pi power. So the easiest way to simplify this is to rewrite it as a fractional exponent. So the 3 root becomes the denominator, and then we'll just simplify that power now. 3 goes into 9 pi 3 times, so it becomes 2 to the 3 pi power, and that is equal to 2 to the 3 times 2 to the, whoops, I didn't mean to put that there, parentheses, 2 to the 3rd to the pi power. Remember, a power to a power, you multiply those powers, so going backwards, 2 to the 3 to the pi becomes 2 to the 3 pi. Now 2 to the 3 is 8, so we can write that as 8 to the pi power, and that's as simplified as it's going to get. Let's try another one of those. That's a little confusing. We'll clarify that. So we have 5 to the 4 pi power underneath the radical, and the understood root is 2 because it's a square root. So we're going to rewrite this as 5 to the 4 pi over 2 using our fractional exponent meaning, and now 2 goes into 4 pi 2 times, so 5 to the 2 pi. Now there's a little shortcut here. Instead of in the last problem, as I split it into 2 little parts there, 2 to the 3 pi is 2 to the 3 to the pi. What you can do is just kind of look at this, do that part of the problem first. So 5 squared is 25, and pi is still the exponent. Same thing here. I could have gone 2 cubed is 8, and pi is still the exponent. Just a little bit faster. We'll do one more and use that faster technique. Let's take the 5th root of 3 to the 10 pi power. We're going to rewrite that as 3 to the 10 pi over 5, which simply becomes 5 goes into 10 twice, so it's 3 to the 2 pi power, and 3 to the 2 is 9, so we just write that as 9 to the pi. So there's all sorts of little tricky problems where you have to simplify radicals or simplify fractional exponents, and that's about all there is to it. Once you know the meaning of fractional powers, you can do all sorts of simplification problems. Alright, that's the end of this video.